Artemis I. It went all the way around the moon, splashed down in the Pacific, and everyone cheered. Mission accomplished, right? A huge success. But hidden inside that success was a pretty serious problem. A problem with the one single piece of hardware that absolutely has to work to bring astronauts home safely. So now, with a crew about to strap in, we have to ask, after what we learned from that first flight, is Artemis II actually safe? And that really gets to the heart of it, doesn't it? This quote from one of Orion's own heat shield managers, and he said this before Artemis I even launched, it points to a terrifying truth about spaceflight. You can run all the tests you want on the ground, build all the computer models in the world, but you never, ever really know how your hardware will hold up until it slams into the atmosphere at 25,000 miles per hour. And when Orion faced that brutal reality, its heat shield came back looking, well, pretty beat up. We're not talking about the expected, even charring you'd see on a system that worked perfectly. No, this was unexpected, significant damage. So the big mystery for NASA, and for all of us, was figuring out just how close to a total disaster Artemis I really got. All right, so let's really dig in here. To understand the risk for the Artemis II crew, we have to understand exactly what went sideways when that first Orion capsule came home. At first, what we heard from NASA was, well, it was pretty chill. They used phrases like, more variations than we expected, and said the material ablated away differently. But then, a report dropped from the Office of the Inspector General, that's NASA's own internal watchdog, and it told a very different story. Those variations, they were actually deep gouges and holes. The material didn't just ablate differently, chunks of it literally blew out. And it wasn't a few small localized areas. Nope, it was in over 100 different spots. Yeah, the OIG report was pretty alarming. It confirmed that chunks of the heat shield material, which is called Avcoat, were just gone. Now, what's really important to understand is how this stuff is supposed to work. Think of it like peeling an onion, one thin layer at a time. It's designed to burn away smoothly, predictably. Instead, it was coming off in chunks, which is a total failure of how the system was designed to perform. And here's where it gets truly scary. This unpredictable damage didn't just create one potential problem. The Inspector General's investigation found count them, three distinct ways this single issue could have led to the complete loss of the vehicle and anyone on board. Okay, so first, those empty spots left by the missing chunks could have let the superheated plasma of reentry burn right through the capsule's structure. Second, those chunks became tiny hypersonic missiles that could have slammed into the top of the capsule and shredded the parachutes. And third, the weird heat flow actually started melting critical bolts, which could have let hot gas get behind the heat shield and literally tear the vehicle apart. The technical term for this is spalling, and it's not just about losing material. The real danger is that when these chunks break away, they leave behind an uneven, pockmarked surface. That unevenness completely messes with the physics of the air flowing over the capsule, creating unpredictable hotspots that can cause even more damage. So let's just put a fine point on this. The Artemis I mission, the triumphant test flight that everyone celebrated, ended with a vehicle so damaged that if a crew had been on board, they could have been killed in 3 different ways. That's the bottom line. Okay, so NASA has a huge problem on its hands, basically a major near miss. What was their explanation? And more importantly, what are they going to do to make sure this doesn't happen when there are 4 astronauts on board Artemis II? Well, after a deep dive, NASA concluded the root cause was trapped gas. As the Avcoat heats up during reentry, it's supposed to create gases that vent away safely. But they found the material wasn't permeable enough. The gas couldn't escape. So pressure just built up and built up under the surface until, pop, it violently blew chunks of the shield right off. Now, the Artemis II hardware is already built. You can't just take it into the shop and swap out the heat shield. So NASA's fix isn't a hardware change, it's an operational one. They're going to change the way they fly the re-entry, using a maneuver called a skip entry, which you can see laid out right here. The best way to think about this is literally skipping a stone across a pond. It's a really clever idea. Orion's going to dip into the atmosphere once, bleed off a ton of speed, and then use its own shape to briefly pop back out into space. Then it comes back in for the final plunge. This breaks that intense re-entry heat into 2 smaller, less stressful events, which NASA thinks will keep that dangerous gas pressure from building up. But here's the billion-dollar question, the one that has a lot of experts really, really worried.
If this new skip entry completely solves the problem and makes the heat shield safe, then why is NASA completely abandoning this design? Starting with Artemis III, every Orion is getting a brand new, redesigned heat shield. That, for any engineer, is a massive red flag. It suggests that maybe schedule and cost are forcing a short-term operational fix for what they know is a long-term hardware problem.
And that's where, for some people who've been around NASA for a long time, the alarm bells start ringing. Big ones. They're seeing some really dangerous parallels to some of the darkest moments in the agency's history. You have to hear this quote from Admiral Harold Gaiman. He's the man who chaired the investigation into the Space Shuttle Columbia disaster. He laid out the grim logic. When you have a technical problem, but you can't delay the schedule and you can't get more money, the only thing left to cut is your safety margin. You start accepting risks you never would have before. And that's exactly what critics, like former shuttle astronaut and heat shield expert Charles Camadorda, are afraid is happening right now. He argues NASA is using what's called motivated reasoning, where you start with the conclusion you want, which is it's safe to fly, and then you work backwards to make the data fit that conclusion, instead of the other way around. So why would NASA, an agency built on safety, even consider taking a risk like this? Well, to get that, you got to look at the incredible, almost overwhelming pressure they're under to fly this mission and fly it soon. First off, follow the money. The Artemis program, in one form or another, has been in the works for almost 25 years. The price tag so far? Somewhere in the neighborhood of $100 billion. That is a mountain of financial pressure to show some results.
And it's not just about the cash. There's intense political pressure to hit deadlines, like landing on the moon before the decade is out. Critics are suggesting that with all that money already spent, what economists call sunk costs, and the need to save face, the agency is pushing forward when the truly safer option would be to fly another uncrewed test mission. So all of this, the technical debates, the budget pressures, the ghosts of the past, it all comes down to one simple, terrifying question. And it comes down to the four people whose lives are literally riding on the answer. These are the astronauts of Artemis II. Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. Their safety, their lives, depend entirely on that one heat shield and on the hope that NASA's new models are right, that this clever flying technique is enough to fix a known hardware flaw. So, in the end, the choice is NASA's. Is this the agency being bold, courageously managing a calculated risk in the grand tradition of exploration? Or is this an institution under enormous pressure convincing itself it's safe to fly while ignoring the incredibly painful, hard-won lessons from Challenger and Columbia? We won't know the real answer until Orion comes home.